Hi everyone, welcome back to my channel. As a part of this brand new series, we are diving deep into one of the most common and dangerous issues, memory leaks in performance testing. We'll break it down step by step with real world examples, visuals, and practical tips that every tester should know. If you find this video helpful, don't forget to subscribe and hit the bell icon so that you won't miss the next episode in this series. Imagine you're shopping online. You added a pair of shoes to the cart and then checked out successfully and closed the browser. But on the server side, that cart object still lives in the memory, which consumes resources forever. If you multiply the same issue by thousands of users during a big sale, then your e commerce application will crash. That's a memory leak. Now, let's try to understand what are memory leaks. A memory leak happens when a program fails to release the memory that is no longer needed. In simple words, your application keeps holding onto objects even though they should have been garbage collected. Over time, this causes increased memory usage, more garbage collection, slower response times, and even crashes. Now, you may think like why performance testers care about memory leaks. So isn't this a developer's problem? Not really. Performance testers plays a crucial role because memory leaks usually appear under sustained load conditions but not under the unit tests. They only show up when the real user patterns are simulated. That's the reason why performance testers are responsible for validating the system reliability under stress and endurance conditions. So, if you don't catch these leaks before production, your app could crash during peak traffic. Think of an e-commerce site going down on a Black Friday sale. Now, let's try to understand the symptoms of memory leaks in performance tests. How do you know your application has a memory leak during testing? Look out the following symptoms. Heap memory is going to keep growing and never stabilizes. And garbage collector runs more often, but memory is not reclaimed. Response times gradually increased in long tests. CPU usage spikes due to frequent garbage collections. And finally, you will see out of memory error or the app is going to crash. In an e-commerce app, this might mean users face slow product searches after hours of browsing or checkout requests start timing out. Now, let's make it concrete with a real world e-commerce example. Imagine we are testing an e-commerce app with 500 virtual users. They browse the products, add the items to the cart, and then they'll do the checkout and log out. Ideally, the memory usage should rise and fall as the objects are created and garbage collected. But in our test, heap memory keeps rising. Investigating further, we find that every completed cart is still stored in the memory because a static list in the cart service never clears old references. That's a memory leak. And under 6 hours of steady load, it brings the whole cart service down. Now, let's try to understand the difference between normal memory growth versus leak. As a performance tester, you should know the distinguish between the normal memory leak and growth. Let's try to understand the normal behavior first. In the case of normal behavior, your heap memory is going to rise and then the garbage collection will trigger and then the memory drops and backs to a stable baseline. Whereas in the leak behavior, whenever the heap rises, even though the GC runs, but the memory never returns to baseline. It just keep growing. This is why endurance test is essential. Short load tests may miss these leaks completely. So in this episode, you learned what memory leaks are and why the performance testers must detect them, and what are the common symptoms and real world examples from e-commerce apps. In the next episode, we'll go deeper into the JVM memory model and we'll try to understand what is heap, stack, and metaspace so you can clearly understand where these leaks occur and how to detect them during testing. Thank you.